Our planet is a place of constant motion. Air and water currents flow across its surface, driven by the sun's energy and the Earth's rotation. From this dance of nature emerge some of the most awe-inspiring phenomena, the cyclones. Cyclones are vast, swirling systems of winds that circulate around a central low-pressure zone. They are nature's powerful heat engines, transporting warmth and moisture across the globe. Their influence on our weather is profound, shaping rainfall patterns, driving ocean currents, and sometimes unleashing destructive forces. Cyclones are not a single entity, but rather a family of storms with distinct characteristics. They vary in size, intensity, and location, but they all share that defining characteristic, a rotating mass of air spiraling inwards towards a low-pressure center. In this exploration, we will journey into the heart of these whirling giants. We'll uncover the secrets of their formation, differentiate their various forms, and understand their impact on our planet and our lives. Imagine a vast, calm ocean bathed in the warmth of the tropical sun. The air above is heavy with moisture, like a sponge ready to be squeezed. This is the setting for the birth of a cyclone. The formation of these powerful storms is a delicate dance between several key factors. Warm ocean water, at least 26.5 degrees Celsius, provides the initial energy source. As this warm, moist air rises, it cools and condenses, forming clouds and releasing latent heat. The rising air creates an area of low pressure at the surface, drawing in more air from the surroundings. The Earth's rotation plays a crucial role here, imparting a spin to this inflowing air due to the Coriolis effect. In the northern hemisphere, this spin is counterclockwise. In the southern hemisphere, it's clockwise. As the cycle of rising, cooling, and condensing air continues, the wind speeds increase and the cyclone begins to take shape. The precise mechanisms of cyclone formation vary depending on the type of cyclone. However, the fundamental process of low-pressure development, air convergence, and rotation under the influence of the Coriolis effect remains consistent. The life cycle of these storms can range from a few days to several weeks. They eventually weaken and dissipate when they move over colder waters or land, cutting off their energy source. The most common type of cyclone, the extratropical cyclone, earns its name from its birthplace outside the tropics. These storms are the masters of mid-latitude weather, bringing rain, wind, and sometimes snow to large swathes of the globe. Unlike their tropical cousins, extratropical cyclones thrive on temperature contrasts. They form along boundaries between warm and cold air masses known as weather fronts. As warm, moist air is drawn into the low-pressure center, it rises over the colder, denser air, creating clouds and precipitation. The rotation of the Earth, coupled with the temperature differences, fuels the cyclone's spin. Extratropical cyclones are often associated with strong winds, heavy rainfall, and dramatic shifts in temperature. One of the most well-known examples of an extratropical cyclone is the nor'easter, a powerful storm that frequently impacts the northeastern coast of North America. These storms can bring heavy snowfall, coastal flooding, and strong winds, often paralyzing transportation and causing widespread power outages. Tropical cyclones, the titans of the cyclone family, are nature's most powerful storms. They are known by different names depending on their location. Hurricanes in the Atlantic and Northeast Pacific, typhoons in the Northwest Pacific, and simply cyclones in the South Pacific and Indian Ocean. These storms form over warm tropical or subtropical waters, drawing their energy from the heat released when water vapor condenses. Tropical cyclones are characterized by their intense low-pressure centers, surrounded by towering thunderstorms and powerful rotating winds. At the heart of the storm lies the eye, a calm, clear region of descending air. Surrounding the eye is the eye wall, a ring of the most intense thunderstorms with the highest wind speeds. The formation of a tropical cyclone requires a specific set of conditions: warm ocean water, low wind shear, high humidity, and a pre-existing weather disturbance. When these factors align, a tropical cyclone can intensify rapidly, developing into a major storm within a matter of days. The Saffir-Simpson hurricane wind scale categorizes hurricanes into 5 categories based on wind speed, with Category 5 being the strongest. Section 5, Subtropical Cyclones, a Meteorological Balancing Act. In the atmospheric ballet, subtropical cyclones occupy a fascinating middle ground. These hybrid storms blend characteristics of both tropical and extratropical cyclones, often forming in regions where warm tropical air masses meet cooler extratropical air masses. Subtropical cyclones typically have a broader wind field than their fully tropical counterparts and lack a well-defined eye. The formation of subtropical cyclones is complex and not fully understood. They can develop from pre-existing extratropical cyclones that acquire tropical characteristics or form independently over warm waters. Subtropical cyclones can bring heavy rainfall, strong winds and rough seas, but they are generally less intense than tropical cyclones. Section 6. Upper-level cyclones. Phantom dancers high above us. High above the familiar realm of clouds and precipitation, invisible to the human eye, dance the upper-level cyclones. These storms exist in the upper troposphere, the layer of the atmosphere where most of our weather occurs. Unlike surface-based cyclones, upper-level cyclones do not form at the Earth's surface but develop in the middle or upper levels of the atmosphere. Upper-level cyclones are often associated with areas of strong divergence, where air is spreading outwards at high altitudes. This divergence aloft can enhance rising motion below, aiding in the development or intensification of surface-based storms. One example of an upper-level cyclone is a cut-off low, a closed low-pressure system that becomes detached from the main jet stream. Cut-off lows can bring prolonged periods of unsettled weather, including cloudiness, precipitation, and cooler temperatures. Section 7. Mesoscale cyclones, small-scale, big impact. While the previous categories of cyclones span hundreds or even thousands of kilometers, mesoscale cyclones are the miniature marvels of the cyclone family. These smaller-scale cyclones, often embedded within larger weather systems, can pack a powerful punch despite their size. Mesoscale cyclones include phenomena like mesocyclones, tornadoes, dust devils, and waterspouts. Mesocyclones, for example, are rotating updrafts within thunderstorms, often associated with supercells, the most severe type of thunderstorm. Tornadoes, the most violent of all atmospheric phenomena, are rapidly rotating columns of air extending from a thunderstorm to the ground. Dust devils, common in arid and semi-arid regions, are small, swirling vortices of air formed by rising air over heated surfaces. Finally, waterspouts are tornadoes that form over water, often appearing as funnel-shaped clouds, descending from a thunderstorm to the water's surface. Section 8. Cyclones beyond Earth, a universe of swirling storms. Our planet is not alone in experiencing the power of cyclones. These swirling storms are a testament to the fundamental laws of physics that govern atmospheric motion, laws that transcend the boundaries of our world. Astronomers have observed cyclones on other planets in our solar system, each with its unique characteristics shaped by the planet's atmosphere and rotation. Jupiter's Great Red Spot, a massive storm system larger than Earth, has raged for centuries. This anticyclone, a high-pressure system with winds rotating in the opposite direction of a cyclone, is a testament to the long-lasting nature of these storms. Saturn, with its dynamic atmosphere, also boasts impressive storms, including the enigmatic hexagonal storm that graces its north pole. Even distant Neptune, an ice giant, experiences powerful cyclones such as the Great Dark Spot observed by Voyager 2 in 1989. Section 9. Naming the beasts, history and impact of cyclones. Since ancient times, humans have witnessed the awe-inspiring power of cyclones. These storms, often unpredictable and destructive, have left an indelible mark on our history, culture and psyche. The word cyclone itself originates from the Greek word cyclone, meaning moving in a circle or whirling, a fitting description for these swirling behemoths. Throughout history, cyclones have been both a source of fascination and fear. Ancient mariners, at the mercy of the wind and waves, developed a healthy respect for the fury of these storms. Today, we have a greater understanding of cyclone formation, structure and behavior, thanks to advances in meteorology, satellite technology and computer modeling. Yet despite our best efforts, cyclones still pose a significant threat to human life and property. Cyclones are named by meteorological organizations around the world to facilitate communication and improve safety. These names, often drawn from lists compiled years in advance, help to avoid confusion and ensure clarity when tracking multiple storms simultaneously. The impact of cyclones on human life is multifaceted and often devastating. Coastal communities are particularly vulnerable to the destructive forces of storm surge, high winds, and heavy rainfall. In conclusion, cyclones in all their forms and fury are an integral part of our planet's dynamic atmosphere. From the towering thunderstorms of a hurricane to the gentle whirl of a dust devil, these storms remind us of the immense power of nature and the importance of understanding and respecting the forces that shape our world. As we continue to study and monitor these whirling giants, we gain a deeper appreciation for the intricate workings of our planet and the delicate balance that sustains life on Earth.